Let's begin with Chapter 5, Estimating Potential Harm and Planning a Response. In this lesson, we will be discussing explain how to estimate the potential harm or severity of an incident, explain how exposures might be affected by various types of hazardous materials incident, describe how to plan an initial response, describe how to select personal protective equipment for an incident, identify and describe the types of personal protective equipment needed for hazardous materials incidents, identify and describe the 4 chemical protective clothing ratings, explain the role of respiratory protection, and describe the basic types of decontamination. Response objectives will be to ensure your own safety, address the potential life safety of those persons affected and potentially affected by the incident. When estimating the potential harm or severity of an incident, hazardous materials incidents response objectives should be based on the need to protect and or reduce the threat of life, property, critical systems. There are 2 main organizations that establish and publish toxicological data used by responders. American Conference of Governmental Industrial Hygienists establishes occupational health and industrial hygiene guidelines and information. It introduced the concept of threshold and limit values. In 1956, an Occupational Safety and Health Administration was created in 1971 with 3 main goals: improve worker safety, conduct research, and publish toxicological data. OSHA also sets permissible exposure limits. PEL is conceptually the same as ACGIH's TLV term. It establishes the standard limit of exposure to a hazardous material. OSHA standards are the law, though. Toxicological values are commonly expressed in units of parts per million, parts per billion, and parts per trillion. Contamination levels in fibers of dust can be expressed through units of milligrams per cubic millimeter. The lower the value, the more toxic the product. The threshold value, or short-term exposure limit, is the maximum concentration of a hazardous material that a person can be exposed to in 15-minute intervals. The threshold limit value, time weight average, is the maximum airborne concentration of a material that a worker can be exposed to in an 8 hours a day, 40 hours a week with no ill effects. The threshold limit value ceiling is the maximum concentration of a hazardous material that a worker should not be exposed to even for an instant. The threshold limit value skin indicates the direct or airborne contact of a material could be result in possible and significant exposure from the absorption through the skin, mucous membranes, and eyes. The recommended exposure level is the value established by the National Institute for Occupational Safety and Health. It is comparable to OSHA's PEL. The designation immediately dangerous to life and health, IDLH, means that the atmospheric concentration of a toxic, corrosive, or asphyxiant substance poses an immediate threat to life or could cause irreversible and delayed adverse health effects. Once exposure values are understood, they can be applied at the scene of a hazardous materials incident. Exposure guidelines can be used to identify 3 basic atmospheres or environments: green environments, which are low hazard and low risk; yellow environments, which are transitional; and red environments, which pose a high hazard and high risk. You have some control over your risk by understanding why and determining how you will interact with the problem. A safe atmosphere is no harmful hazardous materials effects exist, so personnel can handle routine emergencies without donning specialized PPE. Unsafe atmosphere is a hazardous material is no longer contained, has created an unsafe condition for the atmosphere, and persons exposed to the material for long enough may experience some form of acute or chronic injury. Dangerous atmosphere is a serious irreversible injury or death may occur in the environment without any PPE. Resources for determining the size of the incident. Computer programs can be used to model and predict the direction of size of vapor clouds, and the Emergency Response Guidebook outlines predetermined evacuation distances and a basic action plan for chemicals based on spill and size estimates. This example suggests standoff distances for IEDs and BLEVE situations. Now let's discuss exposures. Exposures include any people, property, structures, or environments that are subject to influence, damage, or injury due to contact with a hazardous materials incident. The number of exposures is determined by the location of the incident, physical and chemical properties of the released substance, amount of progress that has been made in protecting those exposures. Isolation of the hazard area. This is one of the first actions responders must take at a hazardous materials incident. Responders and civilians must be kept a safe distance from the release site. Once the hazard is isolated, access is denied to all but a small group of responders trained and equipped to enter the contained atmosphere. Isolating a contained atmosphere is always conjoined in some way with denial of entry to the site. Evacuation is the removal and relocation of those individuals who may be affected by an approach release of hazardous materials. Sheltering in place is a method of safeguarding people located near or in the hazardous area by temporarily keeping them in a cleaner atmosphere, usually inside structures. This is desirable only when the population being protected in place can care for themselves and control their own air, and the structure can be sealed. With reporting the size and scope of the incident, this is accomplished by using information available at the scene. Depending on its size and the extent of the release, may be expressed in units as small as square feet or as large as square miles. Be as accurate as clear as possible when communicating with other responders or assisting agencies and contacting call centers. When determining the concentration of a released hazardous material, concentration refers to the amount of solute in a given amount of solution. A concentration solution contains a large amount of solute for a given amount of solution. A dilute solution contains a small amount of solute for a given solution. Specialized detection and monitoring equipment may be required to determine the concentration levels. With corrosives, for incidents involving corrosives, it is important to know the concentration of the released substance. Concentration is an expression of how much of an acid or base is dissolved in the solution. It is generally expressed as a percentage. Do not confuse concentration with strength. Strength refers to the degree of ionization that occurs in the solution as determined by its pH level. Litmus paper can be used to test the pH. Skin contact hazards, when skin can absorb harmful substances without any sensation to the skin itself. Absorption is enhanced by abrasions, cuts, heat, and moisture. The rate of absorption can vary depending on the body part exposed. Chemicals such as corrosives will immediately damage skin or body tissues upon contact. When planning an initial response, planning the response boils down to understanding the nature of the incident and determining the course of action that will favorably change the outcome. It is important to be mindful of the safety of the responding personnel. Proper incident planning will keep responders safe, provide a means to control the incident effectively. The information obtained from the initial call for help is used to determine the safest, most effective, and fastest route to the hazardous materials scene. Responders need to know as much as possible about the material involved. Different materials require different responses. The characteristics of the area affected near the location of the spill or leak are also important factors. Response objectives should be measurable, flexible, time-sensitive, and based on the chosen strategy. In some cases, several response objectives may be developed to solve a problem. Objectives needed to be tied to the reason you chose to act in the first place. Response objectives fall into one of the three main categories. Offensive operations, which take place in the identified hot zone. Responders take action to mitigate the issue. Defensive actions take place outside of the hot zone or some distance away from the point of the release. And non-intervention occurs when the hazard of entering the hot zone is too great for some reason, allowing the incident to self-stabilize, which makes more sense and is much safer. The mode of operation should be identified in a verbal or written action plan. The main objectives of the IAP include specific objectives, clear work assignments for the responders, the resources needed to handle the incident, an organizational chart representing the key players of the scene, communications channels or methods, a medical plan to follow in the event of responders or civilians are exposed or injured. With personnel protective equipment, the determination of which PPE is needed is based on the hazardous material involved, the specific hazards present, the physical state of the material, a consideration of the task to be performed by the operations level responders. Without the proper PPE, responders place themselves at a risk of suffering harmful exposures. PPE is necessary to protect against skin and respiratory exposure. The National Fire Protection Association publishes protective clothing standards to provide guidance on the performance of certain types of chemical protective garments. NFPA 1991 is the standard on vapor protective ensembles for hazardous materials emergencies and CBRN terroristic incidents. NFPA 1992 is the standard on liquid splash protective ensembles and clothing for hazardous materials emergencies. NFPA 1944 is the standard on protective ensembles for first responders to hazardous materials emergencies and seaborne terrorist incidents. The NFPA does not certify any garments. It provides guidance on manufacturing quality and performance standards. A third-party testing laboratory carries out these testings and certifies the garments in question. These standards are performance documents for the garments only. They are not intended to guide responders. For guidance on which level of chemical protection to use under specific conditions, you should consult the OSHA Hazmat Regulation 29 CFR 1910.120. Appendix B on the OSHA Hazmat Regulation offers guidance on which components should be worn for certain levels of protection and under which conditions the various levels of protection should be chosen. Responders must be aware of the procedures for cleaning, disinfecting, and inspecting PPE. Some types of PPE are required to be tested at regular intervals and after each use. Primarily reusable garments, individual manufacturers have well-defined procedures for maintenance, testing, and inspecting their equipment. Most types of chemical protective garments should be stored in a cool, dry place. Contact the manufacturer before performing any repairs as well. Now let's talk about the types of PPE for hazardous materials calls. OSHA's Hazmat regulations and local jurisdictional regulations spell out the levels of PPE to be used by hazardous materials incidents. Street clothing and work uniforms. These offer the least amount of protection to responders. Structural firefighting protective clothing. This is not recognized as chemical protective ensembles, but it does have a place at a hazardous materials incident. Many support functions can be carried out in structural firefighter gear. A full set of structural firefighter gear includes helmet, bunker coat, bunker pants, boots, gloves, hood, SCBA, personal safety system or PASS device, high temperature protective clothing and equipment. This is a level above structural firefighters gear. It shields the wearer during short-term exposures to high temperatures. It is sometimes referred to as a proximity or entry suit. It provides protection against high temperatures only. Chemical protective clothing and equipment. This is designed to prevent chemicals from entering the body. Not all types are the same, and no single garment will protect you from everything. Manufacturers provide compatibility charts intended to assist you in choosing the right chemical protective clothing. Factors affecting chemical resistance can include time, temperature, resistance to cut, tears, and abrasions. Other requirements are flexibility, temperature resistance, shelf life, and sizing criteria. Chemical resistance is the ability of the garment to resist damage or become compromised because of a direct contact with a chemical. Chemical resistant materials are specifically designed to inhibit or resist the passage of a chemical into and through the material by the presence of penetration, permeation, and degradation. Chemical protective clothing can be constructed as a single piece or multiple piece garment. Common suit materials include butyl rubber, Tyvek, Cernex, polyvinyl chloride, Viton. Fully encapsulated protective clothing offers full body protection from highly contaminated environments. It requires supplied air respiratory protection devices such as an SCBA. NFPA 1911 sets performance standards for vapor protective clothing. Liquid splash protective clothing is designed to protect the wearer from chemical splashes. It does not provide total body protection from gases or vapors. NFPA 1992 is the performance documents for liquid splash garments and ensembles. With chemical protective clothing ratings, the EPA defines levels of protection using an alphabetic system. Level A is a fully encapsulated garment that completely envelops the wearer and the respiratory protection, gloves, boots, and communications equipment as well. It should be used when the hazardous material identified requires the highest level of protection for skin, eyes, and respiratory tract. It is effective against vapors, gas, mists, and dust, and it must meet the requirements for vapor protective clothing outlined in NFPA 1991. The recommended PPE of a Level A ensemble includes SCBA or supplied air respirator, fully encapsulated vapor protective chemical resistant suit with inner and outer chemical resistant gloves, chemical resistant safety boots and shoes, and a two-way radio. Optional PPE for a level ensemble also includes coveralls, cooling vest, long cotton underwear, hard hat, disposable gloves, and boot covers. The Level B ensemble consists of chemical protective clothing, boots, gloves, and SCBA. It should be used when the type and atmospheric concentration of identified substances requires a high level of respiratory protection but less skin protection. The defining piece of equipment for a Level B ensemble is an SCBA or other type of SAR. Garments in ensemble for Level B protection should comply with the performance standards outlined in NFPA 1992. The types of gloves and boots worn depend on the identified chemical as well. Wrists and ankles must be properly sealed with duct tape or some other type of sealant. The recommended PPE for a Level B ensemble includes SCBA or SAR, chemical-resistant clothing, inner and outer chemical-resistant gloves with chemical-resistant safety boots and shoes, and a two-way radio. Optional PPE for a Level B ensemble also includes a cooling vest, coveralls, disposable gloves and boot covers, a face shield, long cotton underwear, and a hard hat. The Level C ensemble consists of the standard working clothes plus chemical protective clothing, chemical resistant gloves, and a form of respiratory protection. Level C ensembles are typically worn in an air purifying respirator or a powered air purifying respirator. Garments for Level C protection must meet the performance requirements outlined in NFPA 1992. The recommended PPE for a Level C ensemble includes full face APR, a chemical resistant clothing with inner and outer chemical resistant gloves, chemical resistant safety boots or shoes, and a two-way radio. Optional PPE for a Level C ensemble includes coveralls, disposable gloves and boot covers, face shield, escape mask, long cotton underwear, and a hard hat. Level D. This is the lowest level of protection. It consists of standard work clothing. It should be used only when the atmosphere contains no known hazard and work functions preclude splashes, immersion, or potential for unexpected inhalation or contact with hazardous levels of chemicals. It should be used for nuisance contamination only. The recommended PPE for a Level D ensemble covers coveralls, safety boots or shoes, safety glasses or chemical splash goggles, and a hard hat. Optional PPE for Level D ensemble can include gloves, an escape mask, face shields. With multiple PPE approaches, a responder may wear liquid splash protective clothing over or under structural firefighting clothing in some situations. Now, with respiratory protection, NFPA 1994 was developed to address the performance of protective ensembles and garments specific to weapons of mass destruction. NFPA 1994 classes include Class 2 liquid splash garment with performance of SCBA. Class 2 standards for PPE are in line with the CBRN requirements for SCBA. Class 3 liquid splash garment performance with APR. Class 3 standards for PPE are in line with the CBRN requirements for the APR. Class 4 performance requirements for particles and liquid-borne variable protection. In addition to meeting the requirements of 1981 NFPA, standards on open circuit self-contained breathing apparatus or SCBAs for emergency services and SCBA or APR with a NIOSH CBRN certification must have passed a battery of tests that measure their performance against sarin and sulfur mustard. The physical capability requirements. The OSHA Hazmat regulation outlines the components of a health and safety management system for hazardous materials responders. It includes medical surveillance, treatment plans for acute on-scene illness and injury, thorough record keeping of all elements of the program, a mechanism to periodically review the entire process. The two primary objectives of a medical surveillance program are to determine whether an individual can perform his or her assigned duties, detect any changes in body system functions caused by a physical or chemical exposure. Responders should be examined by a physician once a year or biannually based on the physician's recommendations. The physician may perform a routine exam based on the expected tasks the employee could perform, conduct a health questionnaire, and take x-rays and perform respiratory function tests, evaluate the individual's fitness for wearing SCBAs and other respiratory protective devices. Specific requirements and guidance may be found in 29 CFR 1910.134. the OSHA EPA NIOSH USCG document OSHA Safety and Health Guidance Manual for Hazardous Waste Site Activities. It covers medical monitoring and support differ from a medical surveillance program. Medical monitoring is the on-scene evaluation of response personnel who may experience adverse effects because of exposure to heat, cold, stress, and hazardous materials. It quickly identifies problems so they can be treated in a timely fashion. The purpose for this is because of the fact that you will be performing these tasks in hot temperatures and cold temperatures where you could be exposed to hyperthermia or hypothermia or even dehydration given the amount of time you may be in there and not been able to hydrate as well. So now let's talk about positive pressure self-contained breathing apparatus. The use of a positive pressure SCBA prevents inhalation and ingestion exposures. It should be mandatory for fire service personnel because the SCBA carries its own air supply. With supplied air respirators, these are referred to as positive pressure airline respirators with escape units. They use an external air source, possibly outside of the confined area, and they are used during extended operations. Units will be equipped with a small escape cylinder of compressed air that provides approximately 5 minutes of breathing air. It is also called the HIP bottle by some agencies. They are less bulky and weigh less than the SCBA, but they may limit movement, and damage can occur if the hose line is contacted with a released product. With the closed circuit SCBA, this is commonly referred to as a rebreather. It can be used when long-term work periods are required. Exhaled air is scrubbed free of carbon dioxide and supplemented with a small amount of oxygen, which is rebreathed by the wearer. It is a closed circuit system because no exhaled air is released into the outside environment. With air purifying respirators, these are filtering devices or particulate respirators that remove particulates, vapors, and contaminants from the air before it is inhaled. They should be worn only in atmospheres when the type and quantity of contaminants are known, sufficient oxygen is available for breathing. Devices range from full face piece, dual cartridge mask to half mask face pieces, mounted cartridges with no eye protection. And cartridge selection is based on the expected contaminants. APRs are easy to wear but have some drawbacks. Cartridges are specific to expected contaminants and are ineffective if the contaminant suddenly changes. Air must be continuously monitored for the known substances and the ambient oxygen level throughout the incident. APR should not be employed at hazardous materials incidents until qualified personnel have tested the ambient atmosphere and determined that the devices can be used safely. With powered air purifying respirators, these are similar to APRs but include a small fan to help circulate air in the mask. The battery-powered fan is worn around the waist and draws air through the filters and into the mask via a low-pressure hose. They are not considered to be true positive pressure units because it is possible for the wearer to outbreathe the flow of supplied air, possibly allowing contaminants to enter the face mask. The main advantages of this is that it diminishes the work of the breather for the wearer. It helps reduce fogging in the mask, and it provides constant flow of cool air across the face. With decontamination, contamination is the process of transferring a hazardous material or the hazardous component of a weapon of mass destruction from its source to people, animals, and the environment or equipment which can act as a carrier. Decontamination is the physical and or chemical process of reducing and preventing the spread and effects of contaminants to other people, animals, the environment, or equipment involved in the hazardous materials incident. Emergency decontamination is the process of immediately reducing contamination of individuals in potentially life-threatening situations with or without the formal establishments of a decontamination corridor. The sole purpose is to quickly separate as much of the contaminant as possible from the individual to minimize exposure and injury. Gross decontamination is a phase of the decontamination process where significant reduction of the amount of surface contamination takes place as soon as possible, most often accompanied by the mechanical removal of the contaminant or initial rinsing from handheld hose lines, emergency showers, or other nearby sources of water. It is performed on team members before their technical decontamination can take place, emergency responders before leaving the incident scene, victims during emergency decontamination, and persons requiring massive decontamination. PPE used by emergency responders before leaving the scene, Technical decontamination is the planned and systematic process of reducing contamination to a level that is as low as reasonably achievable. It occurs before gross decontamination and is intended to minimize the spread of contamination and ensure responders' safety. It is normally established in support of emergency responder operations at hazardous materials incidents. It can be used on victims of the initial release by non-life-threatening contamination exists. Mass decontamination is the physical process of reducing or removing surface contaminants from a large number of victims and potentially life-threatening situations. It is the fastest time possible. Mass decontamination is about making a rapid assessment of the situation and the number of victims present, attempting to identify the contaminant, setting up some form of mass decontamination process which is approved by the authority having jurisdiction, selecting and wearing the proper type of level of PPE, and getting the job done. Emergency field expedient decontamination. This is the process of quickly reducing or removing the bulk of contaminants from a victim as rapidly as possible. It is undertaken in potentially life-threatening situations without the formal establishment of a decontamination corridor. A more formal and detailed decontamination process may follow later. It usually involves removing contaminated clothing, dousing the victim with large quantities of water. If an emergency decontamination area has not been designated, isolate the exposed victim in a contained area. Establish an appropriate location, diverting the stream of water to an area where it can be treated or disposed of later. If adequate decontamination is not performed, the victim should not be allowed to be transported by ambulance to the emergency room or the hospital. The emergency room will actually not admit the individual until decontamination has taken place. Obtain an SDS of the substance to which the person has been exposed to and send it to the hospital with the patient. Ensure your own safety before decontaminating others. Most facilities that use chemicals will have emergency safety showers and eye wash stations available to their employees. Secondary contamination is also known as cross-contamination. It is the process of transferring a hazardous material from its source to people, animals, the environment, and other equipment, all of which may act as carriers of the contaminant. It occurs when a contaminated person or object comes in contact with another person or object. A contaminated victim comes into physical contact with another person. A bystander or responder encounters a contaminated object from the hot zone, the area immediately around the adjacent to the incident. And a decontaminated responder re-enters the decontamination area and encounters a contaminated person or object. Areas at every hazardous materials incident should be designated as hot, warm, and cold based on solo considerations and the degree of the hazard. These are known as control zones. So, in summary, the first priority for all responders is to ensure their own safety while operating at the scene. Hazardous materials incident response priorities should be based on the need to protect and/or reduce the threat of life, property, critical systems, and the environment. To have some frame of reference for the degree of harm a substance may pose, responders should have a basic understanding of some commonly used toxicological terms and definitions. Also gather information from detecting and monitoring devices, bystanders, reference sources, and environmental conditions to obtain a clear picture of the incident. Exposures can include people, property, structures, and the environment that are subject to influence, damage, or injury based on contact with the hazardous materials, or WMD. Immediate protective action should include isolation of the hazard area, denial of entry, evacuation, or shelter in place. Tactical control objectives should include preventing further injury and controlling or contaminating the spread of the hazardous material. Response objectives should be measurable, flexible, and time-sensitive. They should be also based on chosen strategy. Defensive actions include diking and damming, absorption, and adsorbing the hazardous material, stopping the flow remotely from a valve or shutoff, diluting or diverting the material, and suppressing or dispersing the vapors. The decision to act at a hazardous materials incident should be based on the concept of risk versus benefit. The type of PPE required for the incident depends on the material involved and any specific hazards, the physical state of the material, and the tasks being performed by the operations level responder. The selection and use of chemical protective clothing may be the greatest direct effect on responder health and safety. The EPA defines 4 levels of PPE: Level A, which is the highest level, Level B, Level C, and Level D, which is the lowest level. NFPA 1994, the standard on protective ensembles for first responders to hazardous materials emergencies and seaborne terrorist incidents, was developed to address the performance of protective ensembles specific to weapons of mass destruction. It covers 3 classes of garments: Class 2, Class 3, and Class 4. Respiratory protection is so important that it can be viewed as the defining element of PPE. Medical surveillance is the cornerstone of an effective health and safety management system for responders. Before any PPE is worn, hazardous materials responders should be aware of the physiological stress these garments will create. Even though there should be no intentional contact with the hazardous material involved, a procedure or a plan must be established at every hazardous incident to decontaminate anyone who accidentally becomes contaminated. And this is the end of Chapter 5.